Welcome to my presentation on big data, an analysis of data lake and Hadoop. This is presented by John Wesley of Governor State University. Converting data into useful context is one of the more important aspects of helping organizations gain a competitive advantage in the marketplace. And we all know that big data is a forceful concept which drives the strategy for managing information. Given the number of data sources that are now accessible to derive useful insights, such as point-of-service machines, Internet of Things, or wearable sensors, mobile devices, and streaming, all of these elements contribute to the numerous resources that are available for data mining. A data lake is defined as a massive, easily accessible central repository of large data sets. This, in part, is due to the continuous converging of accessibility and interpretation needs that organizations seek to better understand big data concepts. Data lakes consist of structured, unstructured, and semi-structured data elements. And overall, the concept of the data lake is a departure from traditional enterprise level data management sources. Hadoop is a tool used to analyze and assist in the process of converting data into useful information. Hadoop is an open source framework designed largely to transform unstructured data, but is also an effective tool to manage semi and fully structured data. Hadoop is considered scalable, fault-tolerant, with a mechanism to establish distributed storage and processing of large data sets. Given the increased capacity for unstructured data resources, Hadoop is particularly instrumental in layering structure over such sources. Read-on schema is one of the many concepts that's associated with Hadoop, and it illustrates how data can be read in the absence of a fixed format, often demonstrated in the transmission of structured data. The combination of data lakes with the Hadoop framework can provide a shared service mechanism leveraged to deliver deeper analytical insights across a broad, diverse set of data at an efficient scale. A data lake provides the following benefits. A data lake is indiscriminate. It will contain all forms of data, including raw data sources and processed and formatted data. Multiple users have a democratized access to stored data, enabling more opportunities for collaboration when refining, explaining, and enriching data based on unique criteria. In addition to democratization, users have access to robust data sources which originate from multiple sources, which include batch, interactive, online, search, in-memory, and other processing engine sources of data. Hadoop is a comprehensive tool used to harness the contents of the data lake with the architecture required to convert data. Hadoop is a framework with several components used to manage disparate data sets and processes to create useful output. A traditional Hadoop architecture includes the Hadoop distributed file system, which is the layer where data input is for processing. Yarn is the operating system built on a similar framework as Unix, which powers the CPU for Hadoop. And then the data access layer consists of several components, which include but are not limited to MapReduce, which processes batch data, Pig, which processes scripts, Hive and HCatalog, which processes SQL, HBase, which processes non-SQL, Storm, which processes streaming data, and SOAR, which processes search data. The benefits of Hadoop. The combination of Hadoop and the data lake concept allows organizations to increase scope and scale while enhancing performance. Now that former silos are being eliminated, higher efficiency is experienced, which is resulting in better economic results for organizations that seek to leverage data insights to gain competitive advantage. Although the concept of the data lake is indicative of an opportunity to break down information silos and create a more unified construct for data management and storage, it is advised to implement the proper safeguards to maintain fidelity to maximize the full benefit of a data lake. As with any new technology that's offered to the marketplace, there are some cautionary themes that one should be aware of. With respect to the data lake, one of the first cautionary themes is data lakes which are absent of descriptive metadata potentially disrupt the efficacy of quality and will disrupt utilization when tracking the lineage of specific data sets. Additionally, purposeful effort to incorporate security and access measures is required. In its native state, there is little to no discrete security protocols in place within the context of a data lake. Additionally, the democratization of access creates challenges when seeking to decipher the proper hierarchies for data access and control. Mirroring security protocols found in traditional data warehouse settings is the recommended approach, although understanding feasibility is undetermined. And data lakes are most effective when used in conjunctions with applications and tools helpful when aggregating, transforming, and analyzing data. Hadoop is described as a prominent tool to assist in the effort to move data lake constructs to more useful information. The absence of a tool like Hadoop effectively renders the data lake useless. In conclusion, the combination of a data lake and Hadoop will enable the delivery of analytical frameworks to interpret large data sets into useful information. As a low-cost, highly scalable approach, this combination will continue to offer a high degree of effectiveness and flexibility to the end user as this concept continues to evolve. Thank you for listening to my presentation, and I hope this information has been helpful.